Welcome to Levyx's demonstration on real-time persistent computing for big data. Levyx is leading an effort to make big data computing faster, simpler, and cheaper. Levyx's innovative Xenon storage and analytics offload engines are driving the convergence of low-latency computing and persistent storage. We are at the start of a new era we call persistent computing. An increasing percentage of big data workloads need to run faster than batch operations or in real time in order for businesses to compete in today's marketplaces. The time to value benefits of reducing overall application latency are becoming increasingly important. Failure to reduce latency can result in lost sales for e-commerce sites, reduced web traffic on social media sites, and up to $100 million in lost annual profits for high-frequency trading houses for even 1 millisecond of delay. Stack Research observes the 10 and 3 rule for financial markets. Latencies drop by a factor of 10 every 3 years. Levyx has built a query parser that is also an analytics query offload layer with just-in-time compilation, with scale-out clustering capabilities, and also a connector to Apache Spark, all on top of its Helium key-value storage engine. This software stack is called Xenon, and it employs a persistent data frame concept which Spark applications can easily leverage to further accelerate and parallelize their analytics workflow. This data frame-based persistent computing works in the cloud or on-premise, and both accelerates and enables concurrent analytics on the same datasets. Here's an example use case of how persistent computing can reduce the time to value and total cost of ownership. The workflow shown illustrates how a financial institution would backtest a new trading algorithm using historic market tick data to run a series of simulations using particular sets of financial instruments, data ranges, and algorithm parameters to determine the conditions which produce the maximum profitability while minimizing risk. This diagram shows how the previous workflow is now parallelized and transformed into a process that Apache Spark, accelerated by Xenon, can execute against. Because the intermediate processed order stage leverages the Xenon compute-ready persistent data frames, concurrent simulations can be run against the same order books, thereby minimizing the loading or unloading of datasets and maximizing overall CPU utilization. The result is a dramatic reduction in execution time. The Stack Research organization has created an official independent benchmark called Stack A3 that addresses financial algorithm backtesting. They have recently published a report showing that the Levyx Spark Xenon implementation of a benchmark is 32 times faster than any previous benchmark record. Only 4 Google Cloud nodes were needed to execute the Levyx benchmark versus the 14 nodes used for the Hadoop tests. This video illustrates how using both Xenon and Optane can further accelerate the backtesting process. The combined Levyx Spark Xenon on Optane completes 2.3 times faster than stock Apache Spark running on Optane alone. In summary, workloads such as financial algorithm backtesting can simultaneously be accelerated and reduced in cost by refactoring the storage engine layer to take full advantage of the latest multi-core and multi-channel Flash and Optane technologies, which result in increased performance and lower latencies, and building persistent data frames and performing computations on top of this new engine and integrating to big data's most popular in-memory compute platforms, Apache Spark.